Hey guys, so today we're going to quickly talk about congruent triangles. Okay, so the way I'm going to do this is I'm just going to go through a couple examples, or basically just go over the definitions, because mainly in this chapter you just got to know how to be able to figure out what you have in a triangle, be able to prove that true with many different triangles. Okay, so if you look at a basic side-side-side situation, you're given, for example, maybe AB or AC or BC. So you have to prove those are the same as DE, EF, or DF. Simple enough, all you have to know is that you can do this. So side-side-side, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Obviously, they can't be any different in length, or it just won't work, for obvious reasons. So a side-angle side situation, if two sides of an included angle of one triangle are congruent to the corresponding parts. Basically, what this is saying is, if you can prove that two angles are the same in two separate triangles, for example B and E, then you simply know that, for example, EF is the same as BC and AB is the same as DE. Then obviously you can't change the length of AC or DF without changing the angles, which would be B or E in this situation. An angle-side angle situation, basically the included sides mean the sides between two angles. In other words, if the sides in another situation would simply be the angle-side angle situation. Basically, as long as you know that, for example, B is the same as B on the other triangle in this example, and C is the same as C in the other triangle, and then you know that BC and BC are the same, then in no way can BA or AC be any different. They can't, to form a proper angle, they can't change at all. Another situation you might see is angle-side angle. So if two figures of an object are congruent, if they have the same shapes and size. So if one has the same shape, for example, if I could cut off. No, it didn't. That's weird. Another situation you might see is angle side-side. So if two figures of an object are congruent, another situation you might see is angle side-side. Another situation you might see is angle-side. So if two figures of an object are congruent, if they have the same side and shape and size. So basically, you can easily prove this one just knowing two angles on a side. Simple enough. If for example, you were to change angle B or angle A, angle C wouldn't be a proper angle, and it would end up making the lines just drawn. Pretty self-explanatory, kind of like the others. So the hypotenuse leg, basically, this can only apply to right triangles. So if you see a right triangle, and given enough information, this one's most likely going to be correct. This refers to the hypotenuse leg theorem, basically stating that the hypotenuse of a leg of one right triangle are equal to the hypotenuse of a leg of another right triangle then the triangles are congruent. Basically, as long as you know that AB this one is actually fairly simple. For example, AB and DE are the same and then you know that BC and EF are the same, given that C is a right angle, in no way will A or D be able to form proper angles if you change them. Lastly, angle side side or side angle angle cannot be used to prove triangles congruent. They work in some cases, yes, but in most cases you will not see them able to do the job.